So I hope you noticed that sometimes when you try to do period shifts and adjusting the period, it can be very hard to do it graphically. So we really just want to focus on how do we do it algebraically. So that's what we're going to look at for these parts, and that's what I really want you to get from this video. I thought it was important for you to be able to see a graph previously, but I'm not going to ask you to do a whole bunch of graphing when it comes to looking at periods, just recognizing that it's going to either make it a bigger or a smaller period. So both sine and cosine of the parent function have a period of 2 pi. So as we look at general equations, it's going to be y equals a sine bx minus c plus d. And we'll talk about what all these letters mean. You should at least know what two of them, or at least one of them, mean now. And we're going to talk about what the other parts mean too. So cosine would be y equals a bx minus c plus d. And these are what are kind of the general form or the standard equations for a sine and cosine graph. So to find the period, all we are going to do is we are going to take 2 pi, which is our normal period for pi for sine and cosine, and we're going to divide it by whatever is in front of the x. In this case, is the b. And remember, the a gives us the amplitude. So a is amplitude, and b is going to help give us the pi, and we'll talk about the other two later. So find the period algebraically of y equals 2 sine negative 3x. So our b here is negative 3. So we're going to do 2 pi divided by negative 3. So our period ends up being negative 2 pi, or this implies being negative 2 pi over 3. We don't care about the negative. We're just going to say that our period is 2 pi over 3. So every 2 pi over 3, it's going to go through the full cycle. Okay, so for y equals 4 cosine pi x, our b here is pi. So we're going to do 2 pi over b, which is 2 pi over pi. So our period is going to be 2 radians.